Welcome back to Refactoring Paleo Rose, where we modernize an almost 20-year-old Mac app. My name is Tom. My goal for this episode was to take a look at our current NSDocument subclass and figure out how to modernize the code. However, as we'll see, things didn't really go as planned. NSDocument is a very complex class. Since it is the root class for our application documents, we have to manage a wide variety of tasks, including reading and writing the document files, managing file metadata, creating and managing the document's UI, anything to do with iCloud, if we're using it, undo and redo, window restoration, user actions, printing, basically anything to do with the document lifecycle. Thankfully, these roles are spelled out in the Apple's documentation for NSDocument. If you scroll through the page, you'll see methods organized according to their role and how we can overload them if needed. I took inspiration from this organization and reorganized our document class to match the order in the documentation to better understand the code. This is Xrose document, our app's current NSDocument subclass. We will eventually replace this class with something a bit more modern. As I mentioned, I organized this code to match Apple's documentation. And you can follow that organization by clicking the breadcrumbs and seeing everywhere I left a pragma mark that matches a section in the documentation. Something like this. Every one of those flags represents a section in that documentation. So we can navigate and look down to see what we might be overloading in that section. But as you look through here, you'll see that there's just a lot of pragma marks with nothing in them. So these methods were not overloaded either because it wasn't necessary or those methods didn't exist at the time this code was originally written. Now, as we scroll down toward the bottom, we'll start seeing some stuff that isn't organized as it is in the documentation. We start seeing sections in here that are a little different, like awake from nib isn't mentioned in the documentation. Individual accessors, which is a symptom of very old Objective-C code. A delegate pattern, and as we scroll down, responder chain actions, data sets, managing data sets, SQLite database actions. As we keep scrolling, we'll start getting into even importing data, print operation delegates, and apparently unused code. We'll have to investigate this a little bit later to find out if it's genuinely not used code or if it's something that's been temporarily disabled. Now, most of these extra functions are extra work for our document subclass. We have to be very careful about this. We don't want to overload the document subclass to do everything. We want to be very measured about how we use it. And that leads us to looking at some basic ideas around how to make code a little better. The ideas I want to talk about quickly are not to make the code work. It already works. But one of the reasons why this app sat so long is that it's hard to maintain. So let's talk about some of the basics that can help with that. First, let's talk about SOLID principles. SOLID is an acronym for 5 principles that you should follow when writing code. First, we have the S, single responsibility. We don't want to load down a type with more and more work because it's convenient, or we don't know where else to put it. Recognize what the type is supposed to do and leave it at that. Secondly, we have the open-closed principle, the idea that a type is open to extension but closed to modification. In object-oriented programming, inheritance and delegation patterns are used to maintain this principle. Liskov substitution principle posits that classes and their subclasses should be interchangeable, at least at some level. For example, an animal superclass could be replaceable in code with a cat or a dog subclass. The subclasses can have additional functionality, but must ultimately be an interface segregation principle is the idea that to use small interfaces like protocols to represent behavior of types. In Swift, for example, you can create small protocols, combine them together if necessary to provide enough of an interface to be of use. Providing large interfaces for types to use can make adopting those interfaces hard and even harder to test. Dependency inversion principle. Many types depend on something, perhaps a network or database connection. It is tempting, therefore, to create those things where you need it. Instead, classes should depend on abstractions, such as protocols, rather than concrete types. For more details on the solid principles, check out this link, but you can also do a search on it. It's very commonly discussed on the internet. I would also like to take a moment to talk about clean code. While our 20-year-old code works, I wouldn't call it good code. Frankly, I rarely consider any code I've written more than a week ago to be good. But the goal of refactoring is to make the code easy to maintain, test, and easily allow new features or redesign in the future. So the concept of clean code will help with that. Clean code is a big topic in general, and Robert C. Martin's books are a good place to read up on these ideas. So just to name a few things from clean code, we should, 1, follow the solid principles, as we already discussed. You can be very clear about variable and method names. If you use too many abbreviations or 1 or 2 character names, you can also find in a year or two you may not know what those are anymore. So make your names as descriptive as possible. While we also want to get rid of the abbreviations, we don't have to say everything. If we have a list, for example, we don't actually have to call it a list in the name. Code duplication is sometimes required, but be willing to spend the extra time to get rid of that duplication. This can be remembered by the concept of dry code. That is, don't repeat yourself. Duplicated code only creates more work because now you have to maintain the code in multiple places. If you're lucky enough to remember where all those places are, you're always left wondering, are these pieces of code still identical over time? Are there slight modifications you did in one place but didn't do it somewhere else? Function calls can get very complicated. If you can, limit the number of parameters. A huge number of parameters, again, very hard to work with at times. One of my favorite terms that I heard in the WWDC presentation associated with async await is the idea of local reasoning. Local reasoning is the idea that you should be able to look at code and understand it without having to jump around your code base to understand all the pieces. One of the things that this kind of refers to is side effects are examples of not having local reasoning. If you make a call, it should be obvious what that call is doing. For example, if you call into a function to store some data, you might expect to get back a success or a failure result. But should that call update the UI? If it does, that could be an unexpected side effect. It may throw up an error to the user, or it may update some part of the screen. And we may not want to have that side effect happen because it isn't necessarily obvious when you make the call. Many developers love comments, but I find comments should be used sparingly. Instead, when possible, the code itself should be self-documenting. The function name should be adequately designed to describe what the function does. Parameters then should describe the expected types, and so on. If I feel like I need to put in comments, either somewhere inside the function, for example, to describe what the next step is, that's a good sign I should split that code out with a new function or method with a clear name describing what it does. If you can make your code clear, you don't need the comments. This is not to say that comments are always bad. Indeed, documenting APIs for example with docc, is recommended. But comments have to be maintained. If you make a change in the code, do you remember to update the comments? It's arguably better when you're updating the code, you have to update the function names or change the function parameters to adequately describe what's going on. This last on this list, but not at all last, is optimizing signal to noise. Get rid of the junk you don't need. That means unused functions, parameters, types, comments, etc. that you no longer need should be gone. You have a limited amount of time to work on these projects, so you don't want to maintain code that should just go away. Furthermore, be aware of YAGNIs. A YAGNI is YAGNI. You ain't going to need it. Don't write code that you're not going to be absolutely sure you're going to use. Again, that extra code, just because you might need it, is more time, more effort, more testing, and so on. Now, I have a real hard time getting rid of old code. And I often attribute that because I started programming in an era where we didn't have CVS systems like Git or Subversion, where you delete the code, but it's still there somewhere. And on top of that, I'm a bit of a code pack rat. I don't like to get rid of code because, I might have to refer to it again. But today, when you're using these version control systems, the code really never goes away. As long as it was committed at some point, that code will still be there, and you can pull it back out if you really have to. And that means that code really should be deleted. It's still there. It's not in your current code base, but it's still saved. And if you need it, you can pull it out. So how does our document violate some of these ideas? So let's take a look at a few examples. As we mentioned, NSDocument has a lot of work to do. We shouldn't really be adding too much responsibility to that class that isn't already defined. We have to add some things to make it work, but this document is clearly doing too much work. For example, our document is doing a deep dive into SQLite code, for example. Now, again, our document should be handling the document lifecycle, but here it's handling the data model directly. It creates it, manages it, and ultimately deletes it. Now, at a high level and an abstract level, yes, the document has to do that, but it doesn't have to do all the work itself. It can delegate these details of this work somewhere else. Arguably to the document, the details about the data model doesn't really matter. It shouldn't care what shape or technology that underpins the model. If it needs to talk to the data model, it should have a clearly defined interface to do so, and the work can be implemented elsewhere. Meaningful names or symbolic names. Meaningful names and symbolic names. We don't want our code to be cryptic about functions and variables. So let's take a look at an example of where that's going wrong in the code. If we look at this function, we can see several 1 and 2 character variables. Chances are these variables are based on equations to generate these statistics. If we can't lengthen the names to something more meaningful, then this is a good place to add some documentation about the source of these equations and describe the variables in detail in comments. But if we can change the name to make it something more meaningful, we probably should. And indeed, there's no documentation here at all. So when you're using equations like this, it's best to document these things some way. The next thing is avoiding unnecessary terms and names. If we go back to the same function, we are always naming an XR dataset object with the name set. Arguably, that's unnecessary, particularly with Swift. With the lack of type safety in Objective-C, sometimes adding the type info into the name made sense, because you could be sure what that's supposed to be that way. But what if I changed the type when it was declared? If I don't change the name then, our understanding of the code can get muddy. So that's something we should look at. Avoiding duplication. This code is also guilty of duplication. Let's take a look. If you look at the SQLite code, you'll see that we're repeating the same pattern over and over. SQLite has a particular sequence where you have to set up the query, build the query, execute the query, check for errors, And if there are values extracted from the database, then package up those data. But if you look here, we repeat this pattern over and over again. But if we're doing these highly similar things each time, should we really be recreating this code every time we have a query? One of the problems with this is that it's not just in the document. This pattern is repeated throughout the app, since there are many types updating the database. For example, if we do a search for this piece of code in our app, we'll see that a bunch of types are using it. Should they be using it? Probably not. For example, why is this geometry controller, which is really part of the model, why is it doing all these SQLite updates? Not only this issue is related to repeating yourself, but it also goes back to dependency inversion. Because we haven't abstracted away the SQLite code, we are making SQLite code all over the app. Avoiding side effects. Avoiding side effects is extremely important, but our SQLite code gives us an example of this issue as well. Here is the createDB function. Its job is to create the database for the data store. We already established that most of this code should be somewhere else and abstracted away, but it's also doing something that makes sense but raises some implementation issues. If you look at the error handling here, you will see that if an error occurs, the function calls the document to present the error to the user. This makes sense. If there is an error in creating the in-memory data store, we should let the user know about the issue. But this presenting the error to the user is really a side effect. It is not obvious that this is a side effect, however. If we were to abstract this away and have all the SQLite code somewhere else, would we be even able to call present error? Possibly not. This also implies that createDB can fail, but there's no indication in the code that the method can fail. Arguably, that the createDB can fail is a side effect. If you look in the init function for a document, you'll see we are calling createDB and there's absolutely no indication of the possibility of failure, which again is a complete violation of local reasoning. In this case, failing and showing the error are both side effects of this. How would you fix that? Well, there are several ways, but we'll get into that later. If we go back to our createDB function, we'll see that's about 100 lines of code from start to finish. That's also largely duplicated. But as you can see, I added comments here and there to describe what each section of this code was actually doing. So each section is creating a different table in the memory store. This is a prime example where self-documenting code makes more sense than comments. Again, this is largely repeated code, and we want to get rid of the repetition of the code. The only thing here that's truly needed to be unique is each SQL statement. We could do one of two things. We could create separate functions for each of these steps. Each of these steps would have its own function, and the function by definition would have a name stating what it's creating. Alternatively, we could have an array of SQLite statements that we could then one by one step through, and each statement would have a unique name. So either approach would allow us not only to get rid of a lot of the duplication of the code, but it would also document exactly what's going on and eliminate the need of having these comments. Next is signal to noise. I've already mentioned that we have some functions that seem to no longer be of use. In this part of the document, these methods appear to be currently unused in the app. We should delete them if we can, but we should make it clear and get that this particular things were deleted in case we needed to bring some of this code back. Some of this unnecessary code and comments, though, will start going away as we refactor. What's the plan? If it wasn't clear already, this analysis exposes a major problem with this code. It is the SQLite implementation. The way the code was built, the SQLite implementation is not abstracted away from most of the code. As we talked about before, the way the code was built was SQLite. So the way the code was built, the SQLite implementation was not abstracted away from most of the code. Again, we showed earlier that by searching for the SQLite commands, you can see up to 13 types are executing these commands directly. What's kind of important that we haven't really discussed is because this isn't abstracted away, and because all these objects are directly implementing changes to the database, it makes it very difficult to make any kinds of changes. For example, if I wanted to dump SQLite completely, what would happen? What would I have to do to change out that data set? It would mean a lot of work. And we refer to that as tightly bound code or highly bound code, either one. It means that one piece of code is tightly bound to another piece of code. And to split them apart will take a lot of work. And looking back, this pattern that's used in the app, or really an anti-pattern of using SQLite in this way, probably discouraged me from continuing developing this app. That tightness of the code makes myself ask, where can I possibly begin? And when I don't really have an easy answer to that, I'll just go and do something else. It's clear at this stage, if we can change this pattern, the rest of this app will just more or less fall into place. But to change it isn't simple. We're going to have to make this change in stages. We can't do it all at once and keep the app functional for users who want to come in and try it. So if we just totally wait to do any kind of announcements or making releases until this is all done, it may be months or years before that. So we're going to have to do things in stages to break this code out and simplify it. This daunting task will have to start next time. So we will begin abstracting away the SQLite store and our entire in-memory store into somewhere else. And we're going to be slowly migrating away from the pattern that we have now. If that sounds like a lot of work, it is. But if you have any questions or ideas, be sure to add them into the comments. And come back next time and we'll see what we can do about this. Thanks for watching. My name is Thomas Moore, and this has been Refactoring Paleo Rows. Come back again.